Bismillahirrahmanirrahim. Today we will start with our online lectures, and the lecture is about the course on introductory electricity and magnetism. As you know, the course code of this course is PHY104. I will slightly edit this to make this correct. So this is the course code, and this is the 9th lecture of this course, and we will talk about the electric field due to a point charge. So I have written my email address in the footnote of this slide, so in case you have any question, you can email me via my email, or you can just send me a message on KCMS. So what we will talk about today is how to find the electric field of a point charge. We will use the Coulomb's law. We will find the electrostatic force, and then we will use the definition of the electric field to find the electric field of a given charge. And then we will extend this concept to the electric field due to a number of charges. In case we have discrete charges which we can count, like charge number 1, charge number 2, charge number 3, and so on, and we are required to find the electric field. And then we will use the principle of superposition to find the electric field of a given system of discrete charges. And we will at the end of the lecture, we will discuss the checkpoint 1 in your textbook, which I can show you in a moment. If you open your book, so you can come to this topic. This is the 22nd chapter of this fundamental physics. So we have already discussed the electric field lines, and today is the topic 22.2. So you can look here the topic. So we are actually discussing this topic today. So I will come to my notes, this PowerPoint, and would like to start how we can find the electric field of a given charge. So what we'll do, let's start this video, and let me select a pen. I will choose this blue color. So we find, okay, so how can we find the electric field of a point charge? So let's see. So I'll start with the bullet point. Consider a point charge which for simplicity we will consider the positive one, and this charge is, let's say, Q. And if we draw, we can use another color to show this charge, for example. So let's say this plus is a charge which is Q, and the question is that we have to find the electric field at a point P, which is located at a distance, let's say R from the charge Q, and this distance is, for simplicity, let's say this is R. So we are required to find the electric field at the position of point P, and this electric field is due to the charge Q. We also call this charge Q as a source charge. So what we have to do, we have to place another charge and that charge we call the test charge, which we denote by Q naught, following the convention of this book, your textbook. So let's say we place this charge Q naught at point P, and we have to find the electrostatic force between the charge Q and charge Q naught. So the electrostatic force between Q and Q naught. We will use Coulomb's law. So you already know this from Coulomb law, so it's very simple. Just in vector form, 1/4 pi epsilon naught Q naught divided by the distance square, which is r here, and since we have written the force in the vector form, so we can write this vector r. So let's say this is equation equation number 1. So this is the electrostatic force, and if we know the electrostatic force, then we can use the definition of the electric field. By definition of the electric field, that the electric field at a point is the electrostatic force per unit test charge, and if you put the value of F, so you will get the relation 1/4 pi epsilon naught. Q naught will cancel out and you will get r square r. So yeah, so you can also write like this, that the vector, electric field vector, is 1/4 pi epsilon naught and Q divided by r square and r unit vector. So we can enclose this in a so we can enclose this in a box to show that this result is important for today's lecture. So we can also name this as equation number 2. This is the electric field due to a point charge. So we can see that the direction of the electrostatic force from equation 1, it's positive r. It means it's pointing along the separation vector between charge Q and charge Q naught, and it's pointing away from the source charge because the source charge is positive, and the test charge by convention we choose also positive, so the force will be repulsive, and hence the electric field is also have the same direction as the electrostatic force. If we write the magnitude of the electric field or the electric field strength, so we can write or like so we can like this the strength or magnitude of E. So that you can do by simply taking the mod. You can just write like this, mod, and this is 1/4 pi epsilon naught Q by r square, and so there is no unit vector because this is a scalar. So from this we can see that the magnitude of the electric field is proportional to the magnitude of the source charge, which is Q here, and the mod shows that even if the source charge is negative, the strength of the electric field at point P is still the same. Okay, so I mean the electric field strength depends on the magnitude of the charge and the separation of the point where we are interested to find the electric field. So if we place a negative charge at the position of the source charge, and we want to find the electric field strength at the position of P, so we will get the same answer because the magnitude of the minus q is again a positive quantity, so we will get the same electric field. So it shows that the minus or plus sign of the charge shows the direction of the electric field. I mean, in this case, from equation 2 we can see that the electric field of the positive charge is pointing away from the source charge. That you can easily see from yeah, I mean, if you look at your book, you can see yeah, from here and this. So I will keep the changes, and you can go to your book. Yeah, I mean, just look at here. So to do this bigger, when you have a positive source charge, so you can see these arrows which shows the direction of the electric field. So in case of positive charges, the direction of the electric field is pointing away from the source charge, and if you place this positive source charge by a negative one, so then the direction of all the arrows will be opposite, like they will point into the negative charge. So you have to remember this convention, that the electric field, the direction of the electric field for positive charge is always directly pointing away from the positive charge, and the electric field is pointing directly towards the negative charge. So yeah, so let's move forward. Yeah, I mean, from this equation 2, or from the last equation, you can also see that the relation of the electric field vector, or the electric field strength, depends only on the source charge. It has nothing to do with the test charge, because it goes in division and that will cancel out. So the electric field at a point, at any point in the space, I mean, it's the property of the source charge, and it's not the property of the test charge. So more precisely, we can say that the electric field is not related to the test charge. So the next point is the same thing, but in the case of the let's see, draw. I have to choose this, and I have to delete, and then I have to choose yeah, let's start here. And the next point we want to discuss is the electric field due to several charges. Yeah, I mean, we will use in this case we have to use principle of superposition. If I draw, for example, we have a system of charges. Let's say a charge Q1, charge Q2, charge Q3, charge Q4, and so on, as a charge Un. It's a system of n number of charges and we are interested, this represents a system, and we are interested in the electric field of this system at a point, let's say again we consider a point P, which is a distance, let's say R1 from Q1, R2 from Q2, and so on. So what we have to do, so we are required to find the electric field. I will use E for the electric, for simplicity. Electric field at a point P as shown. Point P as shown. I will provide the notes in the PDF version, in which I have a bit a bit extended version of this video lecture, because we cannot take so much time in this video lecture. Don't worry, I'll provide the notes with elaboration in PDF format. So at point P as shown. So what we have to do again, so the same procedure, we have to do the same trick, or the same method, that we have to place a test charge Q0 at the position of point P1, and then we have to find the electrostatic force between the test charge Q0 and the source charges. So we have to do this first for Q1, because we know that the electrostatic force obeys superposition principle. So we can write, for example, the force. We can write the force between the test charge Q0 and the source charge 1. So we can write that this is 1/4 pi epsilon naught Q1 Q0 over R naught 1. R naught 1 means you can let's say R naught 1. If you want to show this distance, for example, so you can use, you have the option. So let's say this is R naught 1. From Q2 it will be R naught 2, and so on. For example, from this one it will be R naught n. So you can write this force for for all the charges separately. So let's see, you can write if not 2, this will be again the same, Q2 Q0 R naught 2 square, sorry, here is square, so it's R naught 2, and so on. F naught n with vector, the same thing, Qn Q0 R naught n square R naught n unit vector. So what you have to do then you have to add all these forces to get the resultant force using the principle of superposition. So F naught, the total force on the test charge Q0 due to the system of charges is just the vector sum of all these forces, F naught 1 plus F naught 2 plus, and so on, F naught 3. Yes, and then if you want to find the electric field, then use the definition of the electric field, the electric force per unit test charge. So you can write as E naught is F naught over Q naught, and you will simply obtain E1 plus E2 and En. If you want, you are wondering what's E1, then E1 is actually F naught 1 divided by Q naught. So yeah, this is E0, E1 plus U2 plus En, and yes, this relation shows that the electric field also obey superposition principle. I mean, we had to we had to use ensure, keep changes, then we had to use, yeah, just to make this a bit clear, to move it a bit up to have a little space for this. Yes, so this shows that the electric field also obey the principle of superposition. So the rule is now clear to you that if you want to find the electric field of several charged particles, then according to the principle of superposition, you have to find the electric field of each charge separately. For example, E1 due to Q1, E2 due to Q2, and so on. And then you have to add them vectorially. Remember that you have to add vectors vectorially for correct answer. If you just add like a scalar number, then you will make problem and your answer will not be correct. So I think that's for the video purpose. I will say that this is enough, because if I want to discuss the checkpoints, I will make a short video for the checkpoint 1 separately to make it a bit easier for uploading. So that's it, and see you soon.